What if I told you that a machine the size of a school bus falling into a planet at more than 111,000 kilometers per hour spent the last 91 seconds of its life recording something that still has no scientific explanation almost a decade later? And what if I told you that this final message, sent from inside the clouds of Saturn, quietly broke a model that some of the smartest minds on Earth had spent 3 decades building, and they still haven't been able to fully put it back together? Before we go one step deeper into this story, do me a small favor. If you love space, if you love real science, if you love the kind of mystery that makes your brain feel alive, tap that like button, hit subscribe, turn on the notification bell, and share this video with one person who still looks up at the night sky the way a child does. That small action helps this channel keep telling these stories the right way, without noise, without lies, without cheap drama. Now let's begin properly. Imagine, just for a moment, that you're sitting inside a quiet control room at NASA's Jet Propulsion Laboratory on the morning of September 15th, 2017. The lights are soft, the coffee is cold, screens glow with numbers that only a handful of people on this planet fully understand. And on those screens, a small green line is holding steady. That line is the voice of a spacecraft named Cassini, and it is speaking to Earth from inside Saturn's atmosphere as it falls. Everyone in the room knows this line is about to go flat. Everyone knows the machine they helped build, launch, and guide across 1.5 billion kilometers is about to be torn apart by heat and pressure. And still, they stare at that line, because the numbers it is sending back in those final seconds are numbers that were never supposed to exist. To understand why those final seconds mattered so much, we need to rewind. Cassini was launched in October 1997. It took nearly 7 years just to reach Saturn, arriving in July 2004. Once it got there, it did not simply take pretty pictures and leave. It stayed. For 13 years, the single spacecraft circled the ring giant 294 times. It flew past Titan, Saturn's largest moon, 127 times. It made 23 close passes over a small icy world called Enceladus. It sent home more than 450,000 images, along with a mountain of scientific data so large that researchers are still working through it today. By the time engineers began planning how the mission would end, they were confident. They believed they finally had a clear picture of Saturn. They believed they understood the strange six-sided storm at its north pole, a hurricane-like structure that has been rotating there for at least half a century, wide enough to swallow 4 Earths side by side. They believed they understood the rings, those glowing bands of ice and dust that make Saturn the most recognizable planet in our sky. They knew how the rings are divided, how nearby moons pull at their edges, how waves travel through them like ripples across a frozen lake. They even believed they understood, at least in outline, the geysers of water shooting out of Enceladus, a discovery Cassini itself made in 2005 that quietly rewrote the science of where life might exist. But there was one place they had never dared to go. A narrow lane, only about 2,000 kilometers wide, tucked between the innermost edge of Saturn's rings and the top layer of the planet's atmosphere. On a map of Saturn, this gap looks like a thin, dark strip. In reality, it was a place mission planners had treated as forbidden territory for over a decade. They believed it was full of tiny ring fragments moving at speeds that could shred a spacecraft in seconds. So Cassini had always been kept safely away from it, until the very end. The final chapter of the mission was called the Grand Finale. Between April and September of 2017, engineers made a bold decision. They sent Cassini diving through that forbidden gap 22 times. Each dive was faster than a bullet, each one a gamble. The first time it went through, the spacecraft was carefully turned so that its huge dish antenna faced forward like a shield, ready to take the hits everyone expected. And then the data came back, and nothing made sense. The gap was almost empty. Not empty in the poetic way, empty in the measurable way. The particle count was far, far lower than any model had predicted. The place that was supposed to be a violent storm of dust and debris turned out to be one of the quietest neighborhoods in the Saturn system. Engineers were relieved. Scientists were confused, because if the gap was that clean, something was actively keeping it clean. Something invisible was sweeping this narrow corridor and holding it open against physics that said it should be filling up all the time. Some researchers suggested Saturn's powerful magnetic field might be pulling charged particles out of that region. Others thought there might be a slow, steady drain of material into the atmosphere below. But the honest truth, even today, is that nobody has settled the question. A gap that was supposed to be dangerous turned out to be strangely, almost suspiciously, tidy. And that was only the first shock. Now, if you are enjoying this so far, and if you feel that little pull of curiosity in your chest, do this one small thing for me. Pause for 2 seconds and drop a comment below with just one word: Saturn. That single word tells the algorithm that a real human is here, listening, learning, thinking. It helps this video reach other minds that will love this story as much as you do. All right, let's keep going, because the next surprise is even harder to explain. As Cassini dove through that gap again and again, one of its most sensitive tools was quietly sniffing the air, so to speak. This instrument was called the ion and neutral mass spectrometer. Think of it as an extremely precise nose. Its job was to identify every molecule and particle that drifted into it, breaking each one down and reading its chemical fingerprint. And what this nose smelled in that gap was not what anyone had prepared for. It found complex organic molecules, not simple gases like methane, which you might expect in the outer solar system, but heavier, larger, more intricate carbon-based structures. On Earth, molecules like these usually need very specific conditions to form. They need the right temperature, the right pressure, the right chemical partners. They need time and stability. But the gap between Saturn and its rings offers almost none of that. It is brutally cold. It is nearly a vacuum. And it is bathed in radiation strong enough to rip complex molecules apart faster than they can form. So imagine walking through a barren desert with no roads, no rivers, no people for hundreds of kilometers, and then finding a fully working watch lying on the sand. The watch is real. You can hold it. You can hear it ticking. But how did it get there? That is the puzzle scientists faced when they saw those readings. The molecules were there. The path that created them was not obvious. Hunter Waite, the lead scientist for that instrument, has been open about how strange the results were. The material falling from the rings into Saturn's atmosphere was not the pure, simple water ice that models had assumed for decades. It was a rich mix. Water was there, yes, but also organic compounds. Tiny grains of silica similar to what we find in sand and rocks on Earth, and other materials that hinted at chemistry happening inside the rings themselves. Rings that had always been treated as passive, frozen, and mostly boring turned out to be quietly alive with chemical activity. Some researchers now suspect that sunlight, working slowly over millions of years, is triggering reactions inside the ring particles that build these more complex molecules step by step. It is a reasonable idea, but the amount and complexity of what Cassini actually measured are still more than those slow reactions can easily explain. The models can move partway toward the answer. They cannot yet reach the finish line. The tiny silica grains added another twist. Their sizes and numbers pointed to a process of grinding, ring particles crashing into each other and slowly wearing down into fine dust. But once again, the numbers did not perfectly match. There was more of this material, and it was distributed differently than the grinding models could produce on their own. All of this material flowing quietly from the rings into Saturn's upper atmosphere has a name. Scientists call it ring rain. Before Cassini, ring rain was mostly a theory, supported by indirect clues. After Cassini, it is a confirmed reality, but a reality that is far heavier, far more chemically rich, and far more uneven than anyone had guessed. In some places, it pours in like a storm. In other places, it barely drizzles, and the pattern does not match the neat symmetry that older models had drawn. Then came the third shock, and this one reached far beyond Saturn. It touched the deepest question of how any planet in our solar system generates a magnetic field at all. Every world with a strong magnetic field, including our own Earth, creates that field the same basic way. Deep inside the planet, some kind of electrically conducting fluid moves and swirls. On Earth, it is molten iron in the outer core. On Jupiter and Saturn, it is hydrogen squeezed so hard by pressure that it behaves like a liquid metal. As these fluids churn, they generate electric currents, and those currents generate the magnetic field that surrounds the planet. There is a rule that every such planet is supposed to follow. The axis of its magnetic field, the invisible line that connects the magnetic north to the magnetic south, must be tilted at least a little bit compared to the axis on which the planet spins. On Earth, the tilt is about 11 degrees. That is why compasses do not point to the true geographic pole. On Jupiter, the tilt is around 10 degrees. On Uranus and Neptune, the tilt is huge, sometimes more than 50 degrees. This tilt is not decoration. It is a mathematical requirement of the physics that generates the field in the first place. Saturn, quietly, has been breaking this rule for decades. Before Cassini, we already knew that Saturn's magnetic tilt was unusually small, less than 1 degree. That was strange enough. But when Cassini dove close to the planet during the grand finale, its magnetometer delivered a number that stunned the team. The tilt of Saturn's magnetic field is less than about 1/100th of a degree, almost perfectly aligned with its rotation axis. This might not sound dramatic at first, but according to a well-known result in physics called Cowling's theorem, a magnetic field perfectly aligned with a planet's rotation simply cannot be sustained by the kind of internal fluid motion we believe drives these fields. Something has to break the symmetry. Something has to tilt the field, even a little. Saturn seems to say no. Saturn seems to be doing something the equations say should be impossible over long periods of time. Michelle Dougherty, who led the magnetometer team from Imperial College London, has stated clearly in her published work that this finding challenges every existing model. Some scientists now suspect that deep inside Saturn, hidden layers of fluid might be smoothing out the small asymmetries before we can see them. Others suggest that different layers of the planet spin at slightly different speeds, quietly hiding the tilt. Nobody knows for sure. It is a real, open, unsolved problem in modern planetary science, and it came directly from those final orbits. If your mind is spinning right now the way mine is, take a breath, and if you have not already, go ahead and hit that subscribe button. Not for me, but for the future videos in this series, because there is still much more to unfold, and when you subscribe, you make sure you do not miss a single one. Now let's move to what many people consider the most beautiful part of the Cassini story, because for all the strange discoveries Cassini made, its greatest gift to humanity might have come from a small, shining moon called Enceladus. Enceladus is only about 500 kilometers across. That is roughly the width of a small country. Its surface is coated in fresh, white ice, so bright and clean that it reflects almost all the sunlight that touches it, making it one of the most mirror-like objects in our entire solar system. From a distance, it looks peaceful, almost too peaceful. But in 2005, Cassini flew close enough to see something no telescope had ever caught. At the moon's south pole, deep cracks were slicing across the ice. Scientists nicknamed them the tiger stripes. And out of these cracks, enormous jets of water vapor and tiny ice crystals were shooting up into space at incredible speeds. Not steam, not gas, actual water. On a moon, smaller than many countries on Earth, far, far from the sun's warmth. This should not have been possible. A world that small, that far away, should be frozen solid all the way through. There's not enough sunlight out there to keep water liquid. Something else had to be heating this moon from the inside. And that something else turned out to be Saturn itself, along with the pull of nearby moons. As Enceladus travels around Saturn, gravity gently squeezes and stretches it, like a hand slowly kneading dough. That squeezing creates friction. That friction creates heat. And that heat is enough to keep an entire ocean of liquid water hidden beneath the ice. Under the frozen shell of Enceladus lies a global sea, and the tiger stripes are cracks in the roof of that sea, sending its water up into space where Cassini could taste it. Suddenly, the map of possible life in our solar system had to be redrawn. Because if a tiny moon far from the sun could hold a liquid ocean, then the old rule that life needed to live in a narrow warm zone near a star was suddenly less certain than we thought. Cassini did not stop there. Over the following years, it flew directly through those plumes, sampling the water as it passed. It found simple organic molecules. It found carbon dioxide. It found methane. It found molecular hydrogen. That last one was especially exciting because hydrogen bubbling out of an ocean is a strong sign that hot water is reacting with rock deep down on the seafloor. On Earth, exactly this kind of reaction happens at hydrothermal vents at the bottom of our own oceans, and those vents are home to some of the strangest and most independent forms of life we have ever discovered. Life that has never seen the sun, life that runs on chemistry, not sunlight. By the time Cassini's mission ended, scientists had confirmed 5 of the 6 chemical elements considered essential for life as we understand it in that hidden ocean. Carbon, hydrogen, nitrogen, oxygen, sulfur. Only one was missing from the confirmed list, phosphorus. And phosphorus is not a small detail. It is part of the backbone of DNA and RNA, the molecules that carry the instructions of every living thing we know. It is at the heart of ATP, the molecule that stores and delivers energy inside every cell. Without phosphorus, life as we know it simply does not work. Cassini did not have an instrument sensitive enough to catch phosphorus directly in those plumes. So when the spacecraft finally fell into Saturn in 2017, the story felt unfinished. 5 out of 6, so close and yet not complete. Then, in June of 2023, 6 years after Cassini was gone, the missing piece arrived. A team led by Frank Postberg went back to the archives. They reopened Cassini's old data and looked at it with new methods and improved understanding. And there, hidden inside grains of ice, they found phosphorus. Not a trace, not a whisper, but strong concentrations of phosphate compounds. In fact, at levels far higher than what we find in Earth's own oceans. Let that sink in for a moment. Every single chemical ingredient that life needs, as far as we currently understand life, is present in the ocean of a small moon around Saturn. Everyone. This does not mean life is there. Ingredients are not the same as a finished meal. But before Cassini, we did not even know the pantry existed. Now we know it is fully stocked. The James Webb Space Telescope has been adding to this story too. Looking at Enceladus from its distant position, it has shown that the plumes rising from that little moon are even larger than Cassini could see up close. Water vapor from Enceladus spreads out into a giant cloud that wraps around a huge region of Saturn's system, feeding one of the outer rings and painting the moon's fingerprints across space in ways never fully mapped before. If you're feeling that quiet sense of wonder, share this video with someone you care about. A friend, a family member, a curious kid, anyone who has ever asked, is there life out there? Because this is the story that gets closer to that answer than most of us realize. Now let's return to Saturn itself. Saturn is quietly doing something strange with its own heat. It sends more energy back into space than it receives from the sun. Jupiter does the same thing, and for Jupiter, we have a reasonable explanation. Jupiter is still slowly shrinking under its own gravity, and that gentle contraction releases heat. But Saturn is smaller. Saturn should have used up that ancient heat long ago. And yet, there it is, glowing warmer than the sunlight it catches would allow. One idea is that deep inside Saturn, drops of liquid helium are slowly separating from the surrounding hydrogen and sinking downward like a very slow rain. As those helium drops fall, they release energy, and that energy escapes as heat. It is a beautiful theory. Helium rain in a place no human eye will ever see, but the numbers still do not fully match reality. The models produce some of the extra heat, but not all of it. Something else is going on. We just do not know what. The atmosphere itself keeps surprising scientists too. That famous six-sided storm at the North Pole, wider than several Earths, has been photographed in detail. It is not just a shape. It contains fast-moving jet streams, embedded vortices, and wave patterns that dance around each other in ways difficult to reproduce. Circles form easily in fluid systems. Ovals form easily. A perfect hexagon that lasts for decades is a much stranger creature, and how it holds its shape is an open question. Then there was the giant storm of 2010 and 2011. One of the largest storms ever recorded on any planet since the Voyager missions. It grew until it wrapped its way around the entire planet, and Cassini watched every stage of it. As the storm churned, it dragged chemicals up from deep in the atmosphere. Cassini's instruments caught chemical signatures that were difficult to explain with the standard picture of Saturn's atmospheric chemistry. One of those chemicals is called phosphine. You may have heard that name in 2020 when a detection on Venus made headlines. On Saturn, phosphine has been known for a long time. But its behavior is a puzzle. It should be destroyed quickly by ultraviolet light in Saturn's upper atmosphere, yet it keeps showing up in amounts that suggest either it is being replaced faster than we thought, or produced by some process nobody has fully identified. None of these questions have been settled. They are all still very much on the table. So when you add all of these pieces together, you begin to see the shape of Cassini's work. It did not deliver a movie ending with a single dramatic reveal. It did something much harder and much more valuable. It showed us that a planet we have watched for 400 years is still hiding basic secrets about how it works. It showed us that a small icy moon we barely paid attention to now sits at the very top of our list for possible life. It showed us a ring system more alive with chemistry than predicted, and it left us with a magnetic field puzzle that shakes core ideas of how planets work. These are not tidy discoveries. They do not close chapters. They open them. And that, in a real scientific sense, is what discovery is supposed to feel like. Not the comfortable feeling of knowing, the uncomfortable, thrilling feeling of realizing how much more there is to learn. On September 15th, 2017, at 7:55 in the morning Eastern Time, Cassini's signal finally went silent. The spacecraft was diving into Saturn's atmosphere at more than 111,000 kilometers per hour. As the atmosphere thickened, its little thrusters fought to keep its antenna pointed at Earth for as long as possible. The team at JPL watched the signal strength on their monitors. Steady, steady, steady. And then, in a single moment, gone. People in that room did not cheer. They did not clap right away. Some of them cried. Because this was not just a machine going quiet. This was 13 years of their lives, ending in 91 seconds of final data. Cassini had been part of the daily rhythm of these scientists for so long that letting it go felt like losing a member of the family. And yet, there was pride. The spacecraft had been deliberately destroyed. If it had been left to drift, it could have crashed into one of Saturn's moons and contaminated a place that might hold life. So the team chose to burn it away in Saturn's sky, keeping Enceladus and Titan pure for the future. But even though the spacecraft was gone, the science did not stop. This is one of the most beautiful truths of space exploration. The data does not die when the machine dies. Every reading Cassini sent sits carefully stored in archives. And as our tools improve, as our understanding grows, as new questions rise, we can go back to that old data with new eyes and see things nobody saw the first time. That is exactly what happened with the phosphorus discovery in 2023. The signal was already in Cassini's records. It had been sitting there for years, waiting for the right minds and the right methods to notice it. And when they did, one of the biggest questions in astrobiology quietly moved forward. Not by launching a new mission, by rereading an old letter with fresh eyes. There is almost certainly more waiting in those archives, more patterns, more clues. The grand finale data alone is still generating new papers every year, new models, new arguments, new ideas. Cassini keeps giving, even though Cassini is no longer there. Right now, in labs and offices around the world, scientists are working on plans for the next great mission to Enceladus. The idea is a spacecraft designed specifically to fly through those plumes with far more sensitive instruments, tools capable of searching for the direct chemical signatures of living cells. Not just water, not just carbon, not just ingredients, but amino acids, fats, and the kinds of complex molecules that on Earth almost always mean one thing: life. That mission has not been fully approved yet, but every proposal stands on top of what Cassini quietly proved. The ocean is there, the heat is there, the chemistry is there. The only question left is the one Cassini was never built to answer. Is anything alive down there? To reach that answer, we will need a new machine, a new set of eyes, and many years of patience, but we now know exactly where to look. That is not a small gift. It is one of the greatest gifts a mission can leave. So let's return one more time to that quiet control room. Picture the green line on the screen. Picture the tired, proud faces of people who had spent decades on this. Picture a small machine falling through the golden clouds of Saturn, glowing red and white as friction tore into it. Its cameras were off by then. Its final data was on its way home, traveling at the speed of light across more than 1 billion kilometers. That data would take about 83 minutes to reach Earth, which means by the time humans saw the signal end, Cassini itself had already been dust in Saturn's sky for well over an hour. There is something almost poetic about that. We were saying goodbye to a machine already gone. And that ghost, that final voice, carried in its last words the seeds of questions that would still be alive years later. Questions about how planets build magnetic fields. Questions about rings being chemical factories. Questions about why a hexagon spins forever at the top of a world. And most importantly, questions about whether we are alone. Cassini did not find aliens. It did not find hidden messages or uncovering secret conspiracies. The real story is quieter, but in many ways much more powerful. It found that the universe is stranger, richer, and more surprising than our best models prepared us for. It found that after 13 years of watching a single planet, we still have to admit, with humility, that we are only beginning to understand what we are looking at. And maybe that is the true lesson of Cassini's final seconds. Not that we know so much, but that we are just clever enough to see how much we still do not know. A small machine, a big planet, a hidden ocean, and a magnetic field that refuses to obey the rules. That is what Cassini left behind. Not answers, better questions. And better questions in science are worth more than gold. So the next time you step outside on a clear night and see that pale, steady point of light called Saturn, remember something. Somewhere inside that distant world, a small silver ghost dissolved into the clouds one September morning, whispering its last words. And those last words are still teaching us, still challenging us, still calling us back. Not to close the book on Saturn, but to open it again, on a page nobody has read yet. Thank you for staying with me until the very end. Keep looking up, keep asking questions. Because the sky, as Cassini proved with its final breath, is still full of secrets waiting for us to find them.